Chapter 3 is about the medium. Communication medium. So it's talking about conducted, it means connected physically, and wireless, or not really physically connected, but through invisible medium, like what microwave or infrared or something like that. So we'll go through that chapter really quick and skim it. And these are the objectives to be covered on the left hand side, and we'll go through that. And the introduction shows that it's either physical or conducted medium, or radiated or wireless medium. And the wireless includes the terrestrial microwave, the satellite microwave, the cell phone systems, the broadband wireless distribution, the Bluetooth, it's also a wireless distribution, or the LAN, microwave LAN, and the free space optics, the ultra-wideband, the infrared. Infrared is also wireless communication, near field communication, when you put the phones close to each other's. And if we keep going, the twisted pair and why it's twisted to reduce noise, and the few figures. And now we are going to talk about the Cat 1, Cat 2, Cat 3, Cat 4, Cat 5, Cat 6, and Cat 7 for each one, and how the first 4 are obsolete and only Cat 5, Cat 5e, Cat 6, and Cat 7 are really in service. So this is the Cat 4, this is Cat 5, which has a better range, and Cat 5e is even better. Cat 6 is currently widely used, Cat 7 is widely used as well, but less than Cat 6. And here is a quick tip about why Cat 5 can transmit gigabit, 1,000 megabit per second, while each one can only transmit 125 megabit per second. They use 4 of them. Still, that's 500, not 1,000. The answer is because they use something called 4D PAM5, and that's 4 dimensions data encoding coupled with 5 voltage levels, PAM5. All right. This combination enables Giga Ethernet to transmit 250 megabit per second over a pair of Cat5e wires, and if they use 4 of them, that's 1,000. And we have the unshielded twisted pair versus the shielded twisted pair. The difference is the shield and the noise. And then we have the summary of the characteristics of twisted pairs. This is the Cat 1, 2, 3, and 4, and they are all obsolete, 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 and obsolete. Cat 5 is used. All right, Cat 5e is better, and Cat 6 is even better. Cat 7 is higher data rate, but it's more expensive. All right. And of course, it's they all operate at the 100 meter, like in the offices or in the houses. All right. So we can just keep going. More characteristics about the twisted pair, and then we just skim that and go to the next type, which is the coaxial cable. And coaxial cables are just like that. It's a copper wire in the middle, then a plastic insulator, then a braided metal shield to remove noise, and then the outer plastic jacket or shield as well, plastic shield for protection. So this is baseband coaxial cable, and thick. There are 2 types, the thick and thin, and here's the pan, and shows the thin and the lower side and the thick and the upper side. And this is a comparison how this is 10 millimeters and this is 4 millimeters, thick and thin. And if we keep going, the more characteristics of coaxial cables, and we have RG6, RG8, RG11, RG58, 59, and 62. And each one is the application here. All right, and we have the fiber optics, then we have the insulated fiber optics like this, and the plain fiber optics without insulation, just like that. And of course, the insulated is protected, but it's more expensive. And we have the two types, the photodiode type that has a photoreceptor, and we have the laser type that it's much better, of course. And we have the fiber optic cable with multiple strands, just like this in the picture, like many cores, many transmission mediums. And here is a fiber optics backbone with Cat6 twisted pair, and I've seen this in power plants. They use fiber optics as a backbone, like like high transmission, high capacity, high bandwidth, connects the switches. And between the switches and the PCs, they use just Cat6 or Cat7 or Cat5e. Okay. Then we have the photonic fiber, and this is a new idea, new concept, where they put holes in the shield, and this allows the air to enter, and they put like an insulator, like a mirror, behind the shield to reflect from the holes and whatever. So yeah, you can read that. So we have more characteristics about the fiber optic cable and the refraction. All right, this is refracted, and the reflection, this is reflected. All right, and single mode transmission and multi-mode transmission. And we have the different labels, 8.3 over 125, and we have the multi-mode fiber transmission called 62.5 over 125. And we'll go next to see the table summary of and characteristics of conducted media. This is all the conducted media: twisted pair, thin coaxial, thick coaxial, lead fiber optic, laser fiber optic. And if we keep going, we will go to the wireless media. Wireless media. All right. Then we have so many details about the wireless media. This is the electromagnetic wave frequencies. This is very interesting, in fact, because it shows the long wave radio, the AM and FM, and the cellular phone here in the gigabits, and the PCs and terrestrial microwave and satellite are all in the gigabit and the gigahertz. And in the terahertz, we have the infrared, and we have the visible light here, and the ultraviolet here. Then we have the X-rays, and then we have the gamma rays. The approximate frequencies are written down there. We can go further in our skimming process. Terrestrial microwave transmission. A typical microwave tower and antenna, all right. Line of sight transmission is required, just like this. Satellite microwave transmission. And by the way, this is also used. The satellite has something called the uplink and the downlink, right? Downlink is from the satellite, and uplink is to the satellite, right? And the propagation delay, and all these concepts. Then we have this Earth, and we have the LEO, the MEO, the HEO, which is like elliptical, and the geo orbits, and each one is explained here. Satellite configuration is mentioned here. This is very nice because it shows beside classified as LEO, MEO, GEO, and HEO, satellite systems can be categorized into three basic topologies: bulk, carrier, facilities, multiplexed Earth station, and single Earth stations. And there are more details here, and there is a graph or a figure that shows the bulk, the multiplexed, and the single. All right. Then we can keep going here and see the GPS system, the global positioning system. And we have the geosynchronous Earth orbit satellite. And the HEO, this is the GEO, and this is the HEO. And the HEO is interesting because highly elliptical Earth orbit. So it's like a big ellipse, and the Earth not at the center, like at the side here. So it come close and go back, and come close and go back, which is similar to the some flying objects in the space. They also follow that criteria. And here we have the very low frequency, the range, and common used in this. Low frequency, the range, and common used in here. Medium frequency, high frequency, very high frequency, ultra frequency, super high frequency, extremely high frequency. So the EHF, extremely high frequency, is used in the radar systems, radars in the military stuff. All right. So then we can go further and see the radar band. It can be L or S or C or X or KU or KA or V or W, and NASA uses the KU, and the GPS uses the L, and the weather system uses the S and the X, and the V is not really used, and the W is for military and car radar system. And now we are done with the radars, and now we will talk about the cell phones and the generations of the cell phones, the first generation, second generation, third generation, fourth generation, fifth generation, because currently we have, in 2022, we have a 5G being commissioned for over a year now, all right, in over 69 countries. So why they call it cellular system? Because it's subdivided into cells. The geographic area is subdivided into cells, and each cell has a base station, like a tower, with antennas. And the office is called MSC, Mobility Switching Office, or called MTSO, Mobile Telecommunication Switching Center or Switching Office, or it's called CTIO, or that CTSO, and this is an abbreviation for, let me check, it's something like telecommunication office or something, CT communication SO, switching office. Let's get that figured out here. It should be written somewhere. So if one call market divided into cells, okay. All right. All right. Cell phones. Anyhow, I'm not sure what is the CTSO stands for, but we can search it here. CTSO. This is 106, and we have in the 108 is cellular telephone switching office. Cellular telephone switching office, okay. And we'll go back, cellular telephone switching office, all right. And we'll go back here and continue skimming. This is a cell tower. Now they look a little bit different. It's like rectangular. They call it brackets or repeaters, and just like these on the palm trees or on the trees. All right. And here a cell phone within a cell communicates to cell tower. All right, we just went through that. Or in fact, we'll just skip that because it's too many details. This is the first generation. Of course, this is a US reference, so it shows US examples, all right, the US companies. And if you read a book from different source, you will see different examples. And the personal communication services PCs. And we have TDMA and CDMA used in the second generation. Then we have the GSM, Global System. All right. Then 2.5 generations supported the GPRS, something called GPRS, which adds speed, add complexity and speed. Then we have the third generation that's called CDMA 2000. Then we have I think this is also 2.5 generation. The third generation starts with the UMTS and a few other companies or standards. Then like this. Then the fourth generation is LTE. In fact, it's a single standard generation, LTE only. Now the fifth generation also, it works over LTE and it's faster. All right, broadband, wireless systems, and WiMAX. So now we're going to talk about channel division. Okay, so this is for more details. It's about the cellular system. It's really interesting how to divide the cells, the area into cells, then group the cells into clusters, then divide the channel, the total number of channels over the clusters, and the like stuff. And here, broadband wireless configuration in metropolitan area. How can we see that? All right, data, internet, long distance. These are communicating through open side wireless bridges, or they call it microwave links and the like, yeah. And here we have the different standards. WiMAX is not really used anymore. Now everything is called Wi-Fi. And I think WiMAX is not used anymore. And it follows one of these IEEE standards. So it's 802.16. Then there's a letter A or B or something. In the Wi-Fi, it's 10, 802.10, and there is also letters in the Wi-Fi. In the Bluetooth, it's also using. It's like still used in cars, and it's wide range. It used the 10 meters distance. It's not really going to 100 meters or something. And data transfer rate is really not really fast, but it's okay. I mean, it works in the cars and in many Bluetooth speakers and some lights as well. Yeah. So if we go to the local area network, we'll see the standards, which is 802.11. A, 802.11b, 802.11g, and all these called Wi-Fi, wireless area networks. All right. And if we keep going, we'll see about free space optics, ultra-wideband, infrared, near-field communication, and Zigbee, and each one of these is mentioned briefly here. All right. If we keep going. So this is the near field, is a newcomer. So the Zigbee, before that, the Zigbee is really energy efficient. So it doesn't really consume lots of power, and the battery can stay for years. And the near field is really short distance, like transfer data from one smartphone to another, like you put them next to each other. They call it near field. All right. If we keep going, this is the summary of wireless media: the terrestrial microwave, typical use, maximum data transfer rate, maximum range, advantages and disadvantages. And this is the satellite, and it has the different types: the LEO, the MEO, the GEO, the HEO, right? And each one has the typical use, the maximum rate, the range, the advantages and the disadvantages. This is the cellular systems, the first generation, which was very limited and low number of subscribers, small number of subscribers, and analog. And then we have the second generations up to the 5, all digital, and they start to become faster and faster. And the PCs, cellular phones, and UMTS, then the EVDR, then the WiMAX, the wireless LAN, the Bluetooth. Each one is mentioned here: the free space optics, ultra wideband, near field communication, very short distances, high speed transfer, depends upon underlying technology, and inches, high speed only for short distances. The Zigbee, low transfer speed, low power. Zigbee is low power, and unlimited distance. And that's it for the wireless. Now, media selection criteria. The criteria is: consider the cost, the speed, the expandability and distance, the environment, and finally security. Number 1, cost. Number 2, speed. Number 3, expandability as distance. Number 4, environment. And number 5, security. 5 factors to be considered in selecting a media. Each one is described here. It's very important to go through each of that to answer the end of chapter questions and exercises, and to master the knowledge, not only skim it. We are just skimming the reference here. We are not really going through details. We are not memorizing words. We are not really understanding in depth. All right, conducted media in action. 2 examples. It's 2 examples, okay? Example of wiring situation involving workstation and a local network. This is the first example. The second, and this is the explanation. And wireless media in action, 3 examples. Now we are going to talk about wireless. And this is the first example: VSA, satellite system for data mining corporation. So this is for satellite dish and satellite, and talking to this headquarter or whatever company in one of the states. Yeah, just like that. Because it's far away. And the cost, the speed, the expandability, the environment, the security. Again, the 5 factors. And here the microwave communication between American insurance companies. So they're microwave antennas with open sides, and it's just 2 miles. So you can see the 2 buildings when you go on the top here and align the dish so they face each other's. All right. The summary of all the chapter is here. This is the whole chapter, the summary of the whole chapter. But again, to answer the exercises, a full read is required. The key terms of the chapter is here, and we have some of the terms here, the new words. All right. Then we have the review questions, like to test yourself to see if you can answer all these questions. Of course, skimming will not enable you to answer all these questions, all right? And exercise, even it's a little bit harder than the questions. And the thing that I like is thinking outside the box. It's really joyful to read and go through, right? Because it makes you thinking about alternative comparisons and what can else be done and all this stuff. And hands-on projects are really nice. One of the interesting questions is question number 9 here, where it says, let me scroll up a little bit, where it says www.fcc.gov. Visit the FCC website and report what frequencies are currently being auctioned. What is now for sale? What frequency bands? Because they sell them. Can you believe that? And this is the end of the chapter 2, and we'll see you in chapter 4 in a few seconds.